Hi everyone and welcome. Today we are going to be talking about control instructions. Control instructions. Assembly does not have anything like if, for, or while. However, it is possible to modify the flow of the program via conditional and unconditional jump instructions. Assembly labels are the location to jump to. So we have the typical layout, instruction, and label. So here, the label can only be defined once and has to be accessible. Now, when your program counter reaches here, where the jump is, it's going to read the label and jump where the label is. So just imagine here a bunch of other instructions. Those are going to be ignored. Conditional control instructions. A condition is tested using CMP, which stands for compare, and the result is stored into our flag. So basically, you're going to have a CMP instruction before the jump, and the jump is going to be executed according to the result of the CMP, right? Now, let's go back to the conditional control instruction. If condition is met, jump where the label is. While before, we're always going to jump because in the unconditional control instruction, we don't have the CMP. Here, we do have the CMP before the jump, so we may or may not do the jump. Now, if the condition is met, jump where the label is, and the jump instruction always follows CMP, as we've just explained. Operator 1 cannot be immediate. Now, this is a bunch of jump that you may use. Please check your documentation because there are much more than that. Pay attention to whether your data is signed or unsigned and choose the correct one. As you can see, we have the unsigned ones. And also we have the dedicated instruction to do the loop. And we're gonna have a look at this one in our example. So basically it works using the RCX register and it jump to label if the register is other than 0. Jump out of range. Generally, if the target label is not within 128 bytes away from the jump instruction, some assemblers might throw the jump out of range error. This error can be fixed by reorganizing the code differently. Iterations. Iterations can be built using previous concepts. So, create and manipulate counters using simple instructions, such as add or sub. Monitor these counters using CMP and change the program flow using jump instructions. Alternatively, you can use the loop instruction. This is the generic form. There are so many of them. You can check the documentation. And all of them are going to be working using the ECX, RCX, CX register, which is used as a loop index. Now, this register is decremented at every cycle, and loop is going to keep cycling until ECX, CX, or RCX is different than 0, which means jumps to label if, right? Now, as this instruction can only have index stored into ECX, CX, or RCX, managing nested cycles is very difficult. Checking documentation. Many other jump and loop instructions do exist. Therefore, always check the documentation. And now, let's have a look at the examples. That's the example. So this example is split in two. The first part is going to have this register over here that is going to be incremented by 1 at every cycle. And then the second part is going to be using the loop instruction. So in here, we are having RCX, which is used as index for the loop. Although we are not using the loop here, we are using the CMP and the jump instruction, right? So we are using this one as an index of the loop, and this is going to contain the number which is going to be incremented at every cycle. And that's the total. That's the label over here. Okay, so we are moving the total, which is contained into the register, into the label. And now we increment RAX by 1. Here we are decrementing this, which, as we said before, is the index of the loop. And then we compare 0 and RCX. So this loop is going to be stopping when RCX is 0, because we are decrementing RCX here, right? In here, we have the jump. So jump if RCX is not 0. So in here, we're going to be jumping here every time. And that's the first part of the program. Now here, we see the same problem, but we're using the loop instruction. So EAX is 0 and ECX is 10. That's the total and that's the counter. So we are adding ECX and AEAX, right? And this is going to be looping if ECX is greater than 0. So if ECX is greater than 0, this is moving here, and we keep on looping. And also, at every cycle, the loop instruction is going to decrement the ECX register, right? Every cycle. Let's see what happens in the debugger. Okay, so we're running the DDD, the debugger, set breakpoint, run, and as you can see, the arrow is jumping every time, right? Now, if I do P, it's 8 because it's being decreased at every cycle, right? If I do it again, 7. So it's working as expected. Now, we're going to get rid of this and we can put the breakpoint in here. We run. Okay, now in here, if I do P 0 and 10, right? Okay, now it's looping. Now I'm expecting the ECX to be 9, right? Let's see again. 7. And then again and again and again and again until the program exits. So, okay, so I hope you've enjoyed my class. Like and share my video and subscribe if you have not subscribed yet. And thank you very much.